The 580 square mile Hanford Site in southeastern Washington state was created in 1943 as part of the Manhattan Project to produce plutonium for the nation's defense program. The discharge of an estimated 450 billion gallons of liquid waste during 40 years of operations resulted in contaminated soil and more than 100 square miles of contaminated groundwater beneath the Hanford Site. For the past couple of decades, waste management, cleanup, and environmental protection from this contamination has been the objective of Hanford's mission. The Hanford Site Central Plateau housed the plutonium processing plants, burial grounds for the waste produced during production, as well as single and double shell tanks that stored liquid waste. These various production-related waste sites, processing structures, and tank farms are all in close proximity to one another. This geographic proximity makes Central Plateau cleanup decision-making difficult when sites are evaluated individually, which is the current practice. The ability to conduct holistic evaluations of groundwater impacts from different cleanup options for these various contaminant sources is key to supporting sound decision-making that is risk-informed and fiscally responsible. The Cumulative Impact Evaluation, or CIE, is a dynamic toolset that consists of multiple integrated computer models that enables regulatory decision-makers to evaluate how different cleanup and closure options impact the underlying groundwater. The CIE was developed to take known information about contaminant migration, as well as estimates based on data collected to date, to better understand the cumulative effects of contaminant movement through the soil, from the waste sites and tank farms within the Central Plateau. Starting with known or estimated contaminant inventories, the modeling system is capable of simultaneously running more than 20 soil column models to track contaminant migration from the surface through the soil column and into the underlying groundwater. These integrated models, each simulating multiple waste sites and tank farms, provide a better understanding of contaminant commingling in both soil and groundwater for decision makers and stakeholders. As the various contaminants are released and passed through the multiple models, accounting of the contaminant migration from one model to the next is accomplished through an integrated computational framework, or ICF. This ICF makes the CIE a unique toolset for overall fate and transport evaluation at the Hanford Site. The integrated toolset can generate simulated groundwater plumes that predict the cumulative impacts of each contaminant at any location. These simulated groundwater plume depictions provide the decision makers a graphical representation of how their decisions on sources originating on the Central Plateau could impact Hanford Site groundwater today and into the future.